All right, Pac Manians, we're back with the final page of 11.6. This first one, I'm going to take a little bit of time to try to explain it just because I want it to make sense to you, but because it's a really common mistake. So it says, verify the reasoning of others. Gerardo says that a cube with edges that measure 10 centimeters has a volume that is twice as much as a cube with sides that measure 5 centimeters. Explain and correct Gerardo's error. So it kind of would right off the bat seem to make sense. If I go from 5 to 10, that's double, right? But if you look at our examples over here, I have 5 times 5 times 5, okay? And that's 125. So I would say 5 times 5 times 5 equals 125, okay? If I double just one side, okay, so let's take this side and I say I doubled that to 10, I would have 10 times 5 times 5, which is 5 times 5 is 25 times 10 is 250. All right, so it doubled in size when I multiplied just the one. Let's say that I double the second side, which I'm going to get to here. 10 times 10 times 5, okay? 10 times 10 is 100, times 5 is 500. It has doubled again, okay? So this is times 2 times 2, right? And if I double it one more time, how much bigger do you think it would be if I did the final one? 10 times 10 times 10. Well, we know that. That's 1,000, right? 1,000, which is double 500, okay? So each time I double the length, right, I double the whole volume of the thing because I'm multiplying, not adding, all right? So each time I change these sides, the volume is going to grow exponentially, which means I'm going to get a huge jump in volume for a small change in length. Just a teeny tiny change in length. Here's a good example. If I have a rectangular prism that is 1 by 1 by 1, well, my volume equals 1 centimeter cubed, right? Now, if I double that to 2 times 2 times 2, well, what's 2 times 2 times 2? It's a small, teeny, tiny change. 1 centimeter to 2 centimeters. It should be twice as big, right? But it's not. 2 times 2 is 4 times 2 is 8 centimeters cubed. This is called exponential growth. Teeny, teeny changes and a huge change, right? So small changes in length give me big changes in volume, and it's the same with area. If I look at the area of a square, 1 times 1, that's just 1. Area equals 1 centimeter squared. If I double that to 2 times 2, area equals 2 times 2, that equals 4 centimeters squared. So I get a huge amount of area change for a small change in length. We did talk about this in one of our earlier lessons earlier this year. So remember, with volume, I'm going to get exponential growth. If you see small changes in numbers, it's going to be a big change in volume, okay? And so we did all the math already over here. So his error is, Gerardo's error is that he is not multiplying things out. Okay, small changes in length means big changes in volume. Okay, just doubling one side will double the entire volume. Doubling all of the sides is going to be 2 times 2 times 2, 8 times as big. Okay, so small changes lead to big changes in volume. All right, I think we did that. Okay, cool. And here's our answers, right? All right, Pia built a rectangular prism with cubes. The base of her prism is 12 1 centimeter cubes. So the volume is 12 cubic centimeters, right? If the prism was built with 108 1 centimeter cubes, what is the height of her prism? So I've got, this is my volume, right? My total volume, 108. So I'm going to write volume equals length times width times height, which equals, this is going to be my area. which is length times width. So this equals 108 equals 12 times some unknown number. So I'm going to show it to you with algebra, but it just means I need to divide 108 by 12 to get my missing number, okay? And what makes that make sense is this is really just 12n. I would divide both sides by 12. And what's 12 divided by 12? It's just 1, right? And then I'll get what equals n. So I have to take 108 and divide it by 12. Well, how many 12s go into 108? It does go in evenly. It is. Look at your 12. Go to 12s. Go down. How far? 9. Right. 9 times 12 is 108. So I got it. So over here, the height. Ooh, I should make that an h. Pretend like I did that from the beginning. All right. So h equals 9. Remember, this is the algebra point. This question is designed, you know that the volume is 108, so I have to divide to get the missing number, okay? It's on the opposite side of the equation. Tougher problem. Packing company makes boxes with edges, each measuring 3 feet. So those are cubes, right? 3 by 3 by 3. What is the volume of the boxes? So one box is length times width times height, which equals 3 times 3 times 3. All right? So I'm going to multiply these out. Is it going to be 9? No, that's if I add them. When I multiply, I get 3 times 3 is 9. Times 3 is 27. So equals 27 feet cubed. That's one box. And it says if there's 10 boxes that make a rectangular prism, what would the volume of that be? Well, that's 27 times 10, which is 270 feet cubed, which should make sense. Okay? So length times width times height. Length times width times height. Okay? Which is the same as area times height. Right? Okay. Anytime they give you area, you're going to need to divide to get the missing dimension. Okay? So remember that. Anytime they give you a volume, you're going to have to divide to get the other dimension. I wanted to show algebra because you know Mr. Pat Geiser always does that. So Carlton used 1 centimeter cubes to build the rectangular prism shown. Find the volume of the rectangular prism that Carlton built. Okay, do that on your own. Come back. Okay, so I've got 4 times 3 times 5. When I look at this, I like 5 times 4 because I know that's going to give me 20, and that's an easy number, but it doesn't really matter. I'm going to do 4 times 3, which is 12 times 5, and 12 times 5 is 60. Boom, got it. Easy peasy, lemon squeezy. All right, homework, and then we're done.